Good day, everyone, and welcome to our third and final day of the conference on empowering learners for the age of AI. So far, the conference has been a wonderful place for learning and networking with people around the globe with a shared interest and passion for AI and learning. We have another great day ahead of us, and starting with our distinguished keynote presenter, Sanna Järvelä. Sanna Järvelä is a professor in learning and educational technology and head of the Educational Technology Research Unit at the University of Oulu. She's also the co-lead of the Center for Learning and Living with AI, funded by the Jacobs Foundation. She's a member of the OECD PISA expert team on living in the digital world and past president of EARLY, the European Association for Learning and Instruction. Sanna's research is focused on collaborative learning, and she's best known for her work on the social aspects of self-regulated learning. So Sanna, I would like to hand over to you for your presentation on socially shared regulation in collaborative learning with AI. Over to you, Sanna.
Thank you, Martin. Actually, very good morning, afternoon, and also good evening. It's late evening here in Finland. So let me share my slide. So here we are. I'm introducing you something about how we are working to advance socially shared regulation with AI. In my talk today, I will first start discussing what do we mean by socially shared regulation in learning. How do we understand that? Where do we build that in the theoretical sense? And also perhaps why it is important now and for the future. I also discuss about theory, why theory is important in this work, but also in the age of AI and AI research. Then I move on discussing about what do we do with AI. So how does it help our research? And finally, I will discuss about why I, as a learning scientist, see AI useful for helping learners to be better learners. So let me start with something very, very important and fundamental, thinking about us as human learners. And that is metacognition. Metacognition is something very, very unique for human learners. It is only something what we as humans have, because we can think about our thinking, we can think about how we think, and we also can think about, for example, how do we feel. So that gives us an ability that we can kind of make mental experiments with our own mental capacities. So it is kind of experimenting with your learning in your mind. So basically that gives you an ability that you can monitor your learning process, but according to that you are also able to change and regulate your learning and something what is going wrong. So in all, metacognition is a very core. I would even consider it as a kind of engine of your mind, because it helps us learners to transfer our mental abilities into the skills and competencies in learning. In this conference, we are discussing about empowering learners with AI, and I think we all agree that and welcome the power of algorithms, and already a long time we have welcomed digitalization for teaching, learning and education, and all this technology which is helping us. But perhaps we should also ask that once we are looking AI in the future, and it is actually everywhere in our life and more these days. So where is the human power? We know the AI power, and it is giving power for many aspects of our life, but considering us as humans, and I think it is some kind of set of uniquely human skills and competencies, something which machines are not able easily to replicate or match. And those are, I'm pointing out to this metacognition, but also to some other abilities very uniquely only to humans. For example, our ability to adapt to new situations and challenges and engage ourselves in complex problem solving. For example, being able to interact, all these social skills which are necessary for communicating and collaborating productively, how we are able to interpret, reciprocally understand each other, for example. All these socio-emotional skills and empathy, for example, which is necessarily part of all these complex problem-solving situations and challenges. And fourthly, for example, the agentic role that we humans can take, ability to take new initiatives and set goals, and also monitor ourselves and others in the progress of their goals. I was pointing out to this monitoring, metacognition, regulation, but also these social interaction and social competencies. And during the recent years, we, especially in our team, we have been investigating collaborative learning. This is, of course, broadly agreed in these days that collaborative learning and computer-supported collaborative learning, for example, is a very powerful learning method. But on the other hand, we also know that it is very complex. Even though we have been investigating decades, almost decades, collaborative learning, we still know that there are a lot of problems. And this is mainly because of complexity of the phenomena. Collaborative learning is never only dealing with knowledge building or cognition, but it is always complex interaction of cognition, motivation, affect, emotions, all activated in social interactions in between different people and their interactions and their styles and experiences and beliefs. And today, more and more different kind of artifacts are part of this collaboration, always with different kind of technologies. So eventually, this phenomena is rather complex to make successful, but also to study as a researcher. Thinking about the phenomena of collaborative learning, regulation in learning, and complexity of the phenomena to study. Theory helps. Some time ago, we had a very nice discussion with colleagues, Ryan Baker and David Schaffer and Zviki. We were discussing actually for making a chapter for a book, Theory Informing Learning from Learning Analytics. And we were discussing in this chapter about the role of theory. And I think we made a very, very strong claim that theory helps us to decide where we are going. We are aware about looking where to go, and theory is helping us to, especially to look what is the next. So thinking about all these opportunities that digitalization and data and AI-based methods give us, there might be very many places to get lost, but and also reinventing something we already know, and perhaps also something which is not useful at all, which seems to be also the case in this area. So definitely theory helps us in proceeding in this kind of research. So the theory I am sponsoring is not new, no, but also not very old. But it is for sure from decades of research that self-regulated learning theory explains in a theoretical and conceptual sense very well those learners who are successful in learning, and also gives very good explanations why some students fail in their learning process. Because the theory explains something on learners' active minds. So it explains why some learners are active and proactive learners, and they also are able to activate different strategical processes in their learning, and they are able to proceed in a goal-oriented way in their learning. Self-regulated learning theory also explains that self-regulation is an adaptive process. It is something that we can very nicely train, augment, and also refine over time. So it is a very optimistic theory and very useful theory thinking about the future learners' needs. Self-regulated learning theory explains individual learners. So it is actually very individually oriented, even in some cases describing individual cognitive architecture. The theory which has been helpful for us is Vinnie's and Hadley's model of self-regulated learning, but because it is focusing on individual minds, we have, together with colleagues, developed the theory and the framework and the concept towards more social context. That theoretical work has made progress with our investigations, trying to understand the components of self-regulation in social context with different data modalities. And with this empirical progress, the theoretical definition of how we define regulation in social context and collaborative context has progressed. Currently, we are still making more detailed conceptualizations about really understanding the core issues in regulation. But at the moment, we are quite well established in our theoretical and empirical work about socially shared regulation. So we consider the concept as a group level phenomena in collaborative learning context, so that socially shared regulation involves groups taking metacognitive control of the task together through negotiated iterative fine-tuning of cognitive, behavioral, motivational, and emotional conditions when they are needed. In socially shared regulation, also self-regulation and co-regulation are part. For example, co-regulation is, according to our research, inviting for socially shared regulation, and self-regulation is always part of socially shared regulation. So different types of regulation modes also play a role in socially shared and group level regulation. When investigating collaborative learning groups and understanding the role of regulation in collaborative learning, we very often have studied in real context in the wild. We always are interested in all these complexities. We really want to get data about all the intervening factors. and the contextual affordances and constraints. Therefore, most of our empirical studies are dealing with different kind of inquiry learning, quite often with science learning inquiries, mainly because those tasks allow enough open conditions for collaborative learning, enough dependency among the students to solve problems together, and also enough challenges to operate with regulation needs. So we are able to study those challenging learning situations. But thinking about the empirical data collection, understanding group learning processes is not and has not been very straightforward thing at all, mainly because when you study collaborative groups, you are always following something which is not static phenomena. It is always temporal, how groups evolve, what happens next, how different collaborative learners are interacting and make the collaborative learning process together. We are not investigating factors in isolation, but more thinking about patterns. So what happens after students are activating certain kind of strategies, or what precedes certain kind of emotional problems or frustrations, and what happens after that. So different kind of patterns and sequences are kind of built in collaborative learning. Also, the problem is that you are never able to implement, for example, one kind of set of questionnaire, because most of the phenomena, the mental intelligent phenomena in collaborative learning are always some kind of socio-emotional or socio-cognitive, combining interaction of cognitive and non-cognitive processes. So you should capture a whole variety of different kind of concepts and phenomena at the same time. Also, technology, different kind of tools, other ideas, different kind of scaffolds and supports are always affording students. So how students are interacting with the contextual conditions, what is the role of the conditions for the collaborative learning process has to be kind of captured. And perhaps the hardest thing in our research has been the sharing issue, like socially shared regulation is sharing, interacting in a metacognitive level. It's not talk, it's not discussion, but something else. And how to capture this sharing has been quite a long time challenging in our research. When thinking about how we as a learning scientist are able to study human learners is actually very, very hard. And I have to admit that it has been hard for us, and I think it is hard to be a learning scientist compared to the medical doctors, for example, because we are not able to see anything any of those metacognitive level affective processes. They are not able to be observed with our methods or naked eyes. Instead of what doctors can do, something they can do biopsy or send a patient to X-ray to scan something, we are not able to scan learning minds. But luckily, digitalization has helped us a lot. And the whole field in learning sciences has made major progress because of learning analytics and digitalization, data, computers, and new opportunities for data collection. And for example, our work, it has been very critical to collect data about those complex collaborative learning phenomena I just mentioned. But learning process multimodal data has helped us to implement different kind of data collection channels and use, for example, high quality video video data collection systems, mobile eye tracking, physiological measures with multi-sensor devices, and implement all these log data, situated questionnaires, and other kind of ways to collect process-oriented data from different collaborative learning situations. Working with those different data modalities, our understanding about socially shared regulation in learning has proceeded during the past years. In our research agenda, our main question still is when, how, and what makes regulation in collaborative learning functional. And we first started to evidence the phenomena. Self-regulated learning is well established in empirical research, but we started to study whether we can find phenomena called socially shared regulation in collaborative learning. And we started to evidence that and found evidence. We also found evidence of different types of regulation modes and how they all are making a function together: self-regulation, co-regulation, and socially shared regulation in collaborative learning. Once we got more digital data, we implemented different data mining systems and process models to understand patterns and sequences, how things, how different cognitive processes are making impact, for example, to the motivational issues, or how affect, what is the role of affect, or what is the role of monitor in students' strategical activities, and so on. Once progressing, the hard thing has been to test the evidence with different modalities, because there is not an optimal set of modalities. None of these data modalities is explaining anything as such, but how to triangulate, how to combine different layers of data features, and so on. And what kind of analysis methods are helpful to us to see and understand something in regulatory processes. Also struggling how to understand this sharing. What is this sharing in metacognitive level? How to understand something. We can understand something nicely among individuals in group, but how to understand how and what level some of the processes are shared. And for example, group level synchrony and so on in the physiological data. But progress has been made, and now we are in a situation that we have been able to collect rather big data sets and combine different data modalities, and we are in the phase that we are able to model and predict some critical processes in socially shared regulation. And this is the stage where AI starts to play a major role in our research. Thinking about AI, why do we need AI? And the explanation comes from the theory. Basically, we don't need AI only because of the data we have, but the phenomena we are studying. The core of self-regulation is a cyclical process, so it is nothing straightforward, easy to be measured as such, but it is always a kind of cycle where students start working, making plans and goals and understanding the task, choosing strategies to progress their goals, and continuously monitoring. And once monitoring progress, then perhaps continuing and strengthening the way they are working, or if needed, if something goes wrong, then adapt, regulate, and change their strategies. So as a cyclical phenomena, we need to understand evidence and model these small scale cycles, and how students are able to face obstacles and how they activate and whether they are able to activate regulation in the face of the challenging situations, and how these small-scale adaptations are growing to the large-scale adaptation where students are really strengthening their learning skills and transferring them to the other contexts. So basically the questions where AI comes useful is, what evidence do we have that the student acts in certain way at some point of time, or how do we understand the process that led to learning in a certain point of time? What happens before and what happens after? And if something happens before, is there something we can help the learners in time so that the learner really strengthens the way how, for example, they work in collaborative learning tasks. Also predicting what the student is going to do next, and eventually how we can really help learners to be more adaptive systematically and be stronger in their learning skills. Perhaps now thinking a bit global perspective, a bigger picture. So once we are working in that way in socially shared regulation, and the field is working hard in AI in education, why this is important and why this is important for a learning scientist, I think this is very clear. We need artificial intelligence in education. For example, we know that by 2025, the world will spend more than $7 trillion on education and training, and only 5% of that is digital. And what is even worse is that quite often that digital opportunities in educational technologies, there is no evidence-based educational technologies which we could support in the decisions we make in large-scale education. We all need that this way we can contribute on evidence-based educational technologies and take the AI as part of that, because simply world is full of all these reports telling that we have not been able to solve the educational problems or the global challenge dealing with education. Today, we have hundreds of millions of children living in crisis areas without no education, and we have not still been able to solve the problems in underdeveloped countries' education. So I think we believe that with the assistance of AI, especially those unique human skills, self-regulation, co-regulation, socially shared regulation, for me especially is important, can be augmented so that we are able to solve global problems. So what we are doing in our team, going back to the real research work in our lab. So we use data. We use data to understand socially shared regulation in learning. And we use AI to make data meaningful for us as a learning scientist. We aim to move on helping learners and AI to collaborate, eventually aiming to augment learners to be more adaptive, self-regulated learners. So basically, we are in a long-term run translating AI to socially shared regulation for evidence-based educational technology. I believe so. As a very recent showcase, what we are doing, without going to any details, I told that we are usually collecting data in the wild, but also we need to sometimes test our hypotheses. And recently we did a rather nice experimental and control study among high school students. They worked with short collaborative learning tasks. They actually designed a healthy smoothie and work with computers and teams to make a nice diet and relevant ingredients for a healthy smoothie. In this task, we collected different data modalities. This is a kind of picture of the setting where students were working, and we had a 360-degree camera and different other systems to collect individual microphones, Keynote cameras, sensors, and so on. Basically, all these different modalities were collected: video, audio, sensor data, and different kind of situated self-reports. What is important in this, of course, this is progressing our conceptual understanding and our research framework and testing our hypotheses. We are testing here something what we call regulatory trigger framework. So we manipulated students' collaborative work with different kind of cognitive challenges and emotional challenges. And for example, this is only a showcase of one student's EDA data in our experiment. But for example, we are able to understand around those challenging situations, cognitive and emotional triggers, students' physiological activations around regulatory triggers, and perhaps then understand in more details some critical situations in collaborative learning. Or what is very typical in socially shared regulation, that some of the aspects like emotional expression or something dealing with metacognition are not able to observed by naked eye, and we are able to perhaps take AI to extract, for example, emotional expressions from collaborative groups and then look at the data and their role of regulation and regulatory processes in more details. To very simplify complex thing, I think this picture kind of summarizes our current aims, how we are working in our team to take AI to augment socially shared regulation in collaborative learning. Basically, we want to collect data or collect learning traces and multimodal data from real collaborative learning situations, so that we have different data modalities and features, audio, video, physiological signals, and so on, so that we can understand something what is otherwise not easily to be understand. For example, currently we are interested in visual cues and the role of visual cues in socially shared regulation. But step by step, all this aiming to understand the role of regulation, but also helping eventually groups to be better and learners to be better collaborative learners. So why this is useful, or is it? Already 70 years ago, Herbert Simon, a well-known Nobel Prize winner, I think in decision-making and problem-solving artificial intelligence, said that machines will be capable in 20 years to do all what humans do. I'm afraid that Herbert Simon was right in many issues, but in this argument he was not correct, I think, and I hope that he won't be ever correct, because I still think that those unique human competencies, we really have to treasure those, and they still are something very important. But what we can do is we know for decades of research that we can always augment us. Tools and technologies, paper and pencil and compasses and calculators, they have always augmented us. But now what we have in our hands, because of digitalization, is the data. But I have to say that any data is not useful for us working in the field of teaching and learning and education. But data is only useful when it is analyzed through the learning scientist lenses, is my argument. Thinking about the AI, again, this is nothing new. Some of us remember those early years when we had those wonderful machines in schools, and we put one student sitting by the computer with intelligent tutoring systems and all these nice computer programs. We knew that intelligent tutoring at that time was very, very useful, but not enough useful, and we learned a lot. We failed because, of course, humans are not machines, and there is more than cognition. It's social interaction, emotions, affect, and motivation which play a role. And soon after that, we learned that actually it is something else, not only that individual cognition or technologies or algorithms as such, but it is all these things around these things. All these interactions, pointing out gestures, social interactions, working with manipulating something which is not otherwise possible, which affords our cognitions. Later on, all different kind of work has been useful. For example, we have understood that actually technologies and tools are very powerful, providing learners on-the-fly support when needed. We've been working with several kind of prompts and scripts and models, and there are very nice examples how dashboards can help our metacognition in individual and group level awareness about certain aspects in our learning processes, and also even orchestrate and script the role of technologies, tools, face-to-face, and other systems. But currently, more and more, it is data and AI. Currently, there is very strong theories and theoretical understanding, understanding how data, AI-based methods can help us, for example, understanding about role of prompts, how different kind of intelligent agents can support self-regulated learning, like Roger Acevedo's MetaTutor. We have learned a lot about the role of multi-channel data and intelligent tutoring systems and self-regulation. Also recently, our colleagues like Inge Molenaar is working with the data to understand more like moment-by-moment learning curves and then giving correct, timely, personalized feedback. And also colleagues are more taking strong theory and AI and data to understand about these processes and help learners. What do we do in our team is quite a lot of that work earlier and now is still an individual, how AI can help individual learners. So I think we still should be a bit more ambitious and think about how we can broaden the perspective. Where we work is the theory in two levels. So first of all, I think we have to overcome something more, or we have to understand something more deeper in regulation, because what we have now in our hands are not regulation. Regulation is much more complex mental phenomena that patterns or sequences or trace strategies can explain. So, and also in a theoretical sense, we don't understand about all that events, for example, that determine regulation. But I think that that AI can work with learners to facilitate socially self-regulation by detecting those challenges and perhaps learners' regulatory responses or lack of responses, and then provide recommendations in real time. Finally, we are currently on a situation that we are working with a theoretical framework, still a trigger concept framework, and a hybrid human AI self-regulated learning model, which Andy Wing is developing in our team currently, so that we can combine those two in order to progress in our research agenda. Still, something to concern. Even though there is very nice progress, there still are some real concerns, because the fact is always that learning is contextualized in the lived experiences. And the question whether the data we have our hands, whether does it really correspond to the observed events, because we as learners, we are humans, we interpret things according to our beliefs in real situations, using all the resources we have available. And the data gives us patterns, sequences, regularities, causalities, and models. And I think these two areas are something that we have to keep in balance in understanding, building theories, renewing theories, and also working with empirical research and perhaps developing new systems. So finally, to the conclusions. First of all, during the past 5 years, we have been working in our university with a large profiling project called Gen Z. The whole idea has been to work together in a multidisciplinary way to co-evolve human sciences and technology research in order to be more alert to solve future problems and provide opportunities for new generations. What we have learned is that this is hard, this is multidisciplinary, and of course it also is quite resource intensive, so you have to network, provide, create teams, but it also needs a quite interdisciplinary perspective, and I will show you with a couple of minutes video about the stage of where we are in this Gen Z research currently, and then continue with some of the future plans. Okay, that was something about, and actually I wanted to show that video because that is how Oulu looks today. We have very nice snow and winter here. Few other issues where we are working currently. We are working with Cella, which is a Center for Learning and Living with AI. This is something I'm leading together with Inge Modelar from Radboud, and we are 5 teams in Oulu, Radboud, in Munich with Maria Bannert, Monash with Dragan Kasevik, and in Florida with Roger Acevedo. We have been working already a long time to understand multimodal data and self-regulated learning, but now we are pushing towards more AI, detecting learning processes, self-regulated learning, and also taking step-by-step more complex learning situations, different technologies, collaborative learning settings, and so on. AI to understand learning, but also provide perhaps some adaptive support so that we can especially equip young learners to learn and live and work in the age of AI. Finally, here in Oulu, the next 5 or actually next 6 years, we start in January 23 with a very big hybrid intelligence research profiling project. This is again multidisciplinary efforts, and our aim is to work with AI and humans so that they can reinforce each other in ethical, responsible, and productive ways. And eventually, we are also taking other realities like metaverse as a forum step by step for hybrid intelligence. After a couple of years of basic research, we are able to move to the implications and helping quality of life, especially in the field of education, and perhaps some other fields like nursing and augmented care. So, and my last message is that the reason why we are working for theory building and empirical work for developing metrics for socially shared regulation is that AI and adaptive systems help learners to be metacognitively aware. So we don't, of course, want algorithms take the power, but we want learners to have the power because we want learners to learn to be adaptive. And finally, I would like to thank you. And of course, this is collaborative work with my team here in Oulu and also with our international collaborators. Thank you.
Thank you, Sanna. Thank you for this wonderful talk and these great examples that you gave during your presentation. Now, there are a number of questions in the Q&As, and maybe the one that I would like to pick up first, if you don't mind, is a question from Hong Xing, and it's about, is there a difference between self-regulated learning and self-directed learning?
Yes, that's a very good question, because self-directed learning is coming from different tradition, and self-directed learning is kind of focusing on someone being able to take everything in own control. But self-regulated learning is continuously helping learners to be better learners. So it is also training learning skills, training to be more strategic learners. And I think that in education, we absolutely should talk about self-regulated learning. Self-directed learning might be much more useful in some other context than in education.
Yeah, thank you. I think that's a very clear distinction. A bit of a discussion perhaps has been raised by Mustafa and in the Q&A, and he's talking about the fact that do we need to connect theories of metacognition with the new context of cognitivism or connectivism, just to understand sort of like how do we think about changing of learning in the digital age, and how do the metacognitive theories that have been applied and more coming from a cognitive era, how do they adapt to the new situation? So do we need to reinterpret, or do we need a new metacognitive taxonomy to relate to the learning of the digital age? I hope I rephrase it correctly, but that's
yeah, this is very hard question. Very hard question. I think that some of the core understanding about how people learn are very strong and clear. And the definitions, things vary, and we know that we use different concepts, but the basic understanding is very strong. But how we use these different components to make bigger theories, or how we operationalize them, they are more generative. And I think because we have new opportunities to empirically evidence something, I think we have to challenge also the old theories. So I think my answer is yes and no.
Yeah, and I think with your multimodal approach, I think you already demonstrate that that's particularly the case, because the cognitive theories also come more from an individual sort of research stem, if you like, and in all your work in the collaborative learning is already connecting with more social learning theories, network theories. And that sort of relates me to another question that has been raised in the Q&A. It's an anonymous question, so I don't know who has been asking this one, but it's about if your work has been informed by complex systems theory or complexity theory.
I recently discussed that with Jeff Green, who is working in self-regulated learning area, and some of my team members are following that. I have to say that there is something important, but complexity theory is enough complex at the moment for me that I would say that there is some interesting things that we should study.
Yeah, I think with again, maybe with the multimodal, but complexity theory is also about understanding sort of the interactions and interrelationships that are happening within these systems that are so complex that you can't really use a linear approach to understanding causal and effect, basically. And I think when you were talking about your trigger events, I think that could be quite interesting to understand sort of how in this sort of complex constellation of collaborative learning and socially shared regulation of learning, how do we understand sort of what triggers effects within and between people during that learning event, so to speak. And I would be quite interesting to sort of see how complexity theory might have a role to play there, to see, okay, well, you know, how do things trigger off one another, and how do you see that back, or how do you trace those feedback loops, so to speak, within your data? I think that could be quite an interesting way of looking at it. I also had a question myself around the triggering events, because I'm always quite interested by triggers and critical events during collaboration, because they might spark something that energizes people to either contribute, or things may fall apart and stuff like that. So understanding triggers for me in collaborative learning is really important. And I was wondering, within the data sets that you have been collecting so far, have you been able to find certain patterns of triggers or triggered events during complex problem solving? Let's just focus on complex problem solving, which is big enough in itself. But if you can find certain patterns, or have you found certain patterns, I think that could be quite interesting.
Yes, I think we have an opportunity, because we have also experimental and control setting data, but actually we have been more interested in learners' responses to those triggers, because then we are able to study regulation. Regulation is not something which students just activate. Regulation is not like knowledge construction, but we use these trigger events as a kind of challenges, so that then we are probably able to see what happens, and whether students are able, whether they invite students for regulation or whether not. But yes, I think that would be important to understand, especially something dealing with collaborative learning challenges.
Yeah, thank you. I think like you say, if you highlight triggers, you can use these triggers to understand self-regulation, and that'll be important for support and development of theory. But I was thinking more differently. If we can understand and find patterns within these triggered events, then maybe we can use AI modeling to start predicting certain triggers that we know that will happen during the complex problem-solving stages, so to speak. So I was more coming from another perspective as well. So not so much from further unpack the theory around sort of, what is happening when these trigger events are occurring, but more to anticipate them and see if AI can play a role in supporting the socially shared regulation process by predicting them.
Yes. I think this is something we are planning to proceed in later when we have new kind of data available.
Nice. Yeah. There's one final question here, and that's from Nadia, and it's about how to assess or measure the performance of teams in SSRL, the socially shared regulation of learning.
We have been not very good we have been more interested in learning processes than the product of learning. But recently we have added always certain kind of collaborative learning products or certain kind of small tasks, or students have been made concept maps or certain other issues that we have been able to evidence about the product of how students have worked collaboratively. But what the question is also that what do you expect? Do you expect students to perform excellent answer or new ideas or multiple ways of demonstrating something? It also depends on the task definition, what kind of task students are working.
And that makes it very situational, I would imagine.
Absolutely. Yes.
Yeah. Okay, well, I don't see any other questions coming up, and we're approaching the hour. So I hope I would join everybody in sort of thanking you for this great presentation and sharing your insights in your excellent work. And it's been a joy listening to your talk, Sanna. Great stuff.
Thank you. Thank you for this opportunity, and I wish everyone very nice conference today.
Okay, thank you, and have a good
Bye.
evening. So, bye.